Okay, a question has come through my email, and it concerns the question of by what factor y changes between two x values. So here's a portion of the x-axis, let's say. I'm not going to draw the y-axis. I'm not going to tell you where the y-axis is. It might be over here, it might be over there, it might be somewhere in between. It doesn't matter to answer this question, although when we use the question to characterize the graph, we are going to need to know, we're often going to need to know where the y-axis is, okay? So anyhow, here's the x-axis, here's a curve, and I'm going to just locate 2 points on the x-axis. I'm going to locate a point here, and I'm going to locate a point here. Okay, so now how big is the y value at this point? And how big is the y value at this point? And what we're used to doing is you project up to the graph and over to the y-axis. We don't have a y-axis. We project up to the graph and over to the y-axis again, but we don't know where the y-axis is. So what else could we do? Well, a little more direct. Way to do this would just be to draw an arrow that represents the y value. So here's your first y value, and here's your second y value. Okay? Now, first question. Is this y value more or less than double this y value? Okay? First, of course, we'll ask, is the second more or less than the first? And it's clear that it's more. And we're talking about the second y value. And we might indicate that these are our chosen x values. That would be this value and this value on the x-axis. And here are the resulting y values, okay? And the resulting y values will be indicated by the arrows. Okay, well, is the second y value more or less than the first? More, clearly. Is the second y value more or less than 2 times the first? Okay, now what do you think? Stop and think about that. Well, okay, here's the first y value. Twice the first y value would be this and this, so it'd have to be this big. So this y value would have to be this big in order to be twice the first, and clearly that's not the case. It's not that big. So we could, well, now we need to estimate, okay, is it 1.5 times as big? Well, we'll say here, let's say this is less. Okay, is the second y value more or less than 3/2 of the first? Well, 3/2 of the first. Here's half of the first. Here's another half of the first. And here's another half of the first. That would be 3/2. Of course, 3/2 is equivalent to 1.5. And it should be pretty clear that the second y value is somewhat less than 3/2 of the first. Well, so, okay, so it's less. Okay, now is the second y value more or less than, okay, well, 3/2. What we've done is we've cut this first one in half, and we've used halves to build up. Okay, what we're going to do is we're going to cut that in half, so we have 1/4 of the first y value. So we have 1/4 of the first y value added to the first y value. Is that more or less than the second y value. So that question becomes, is the second y value more or less than 5/4 of the first? Well, I don't know, I'm unsure. It looks like that's about right. Okay, this looks about right. So it looks like the second y value is about 5/4 of the first. Now 5/4 is 1 1/4, 1.25. And I'll say the second y value as a factor of the first is 1.25. So this y value over this distance, this x distance, has grown by a factor of 1.25. So over x distance, and here's your x distance. So over x distance, represented by this arrow, y changes by factor 1.25.